scooch this over here. We are moving on to Chapter 3. Chapter 3, Lesson 1 should be fairly easy because we are going to be learning multiplication properties, which are very similar to some addition properties that we already have talked about. So, let's look at our first one. The properties of multiplication, together with the distributive property, can help you multiply quickly and correctly. There is something called the commutative property of multiplication, the commutative property. We've already learned about the commutative property of addition. So who can tell me what the commutative property of multiplication would mean? Remember, the word commutative means what? Commutative, yes?
It means commute, and it's where you just switch the places of the two numbers.
Exactly. To commute somewhere means to go back and forth, to change your position. So the commutative property of multiplication means that you can change the position of the numbers and get the same product, right? The two factors can change position, or three or more, and you get the same product. Do you have a question, Shepard?
No, I was gonna say I was gonna do for
Okay, for commutative. Okay, so let's look at this. Commutative property of multiplication means changing the order of the factors does not change the product. All right, let's look at some examples. All right, nobody should have your pencil in your hand yet. Let's look at our example right here. 3 times 4 equals 12. The same as 4 times 3 equals 12. So if you had 1 times 2 times 3 times 4 times 5, it'd be the same as 5 times 4 times 3 times 2 times 1. Or 2 times 5 times 4 times 3 times 1. It doesn't matter the order. Factors can all switch places. They can commute, right? Go back and forth. The commutative property of multiplication says you can change the position of the factors, and it will not change the answer or the product. Capiche? Capash. You've got this one down. We've already learned that one for addition, and it's the same. Okay, moving along to the associative property of multiplication. We had the associative property of addition. This is the same, but with multiplication. Who can remember the associative? What does the word associative mean? Think of like the root word of associative. Shepard?
it's like you group differently, like so 10 times 3, like in parentheses,
Yes.
and then on this side it would be like a 4 or something.
Yep. You're exactly right. And he said a key word. He said grouping. Associative property. If you ever get them mixed up, think of the root word. What is the root word of associative? It is associate. If you associate with somebody, you're kind of in their group. You're in like their clique. You hang out with them. So the associative property, I'll wait till I've got all eyes up here. Otherwise you won't know how to do your work. The associative property means you can group together factors in different ways and still get the same product. Let's look at their exact definition. Changing the grouping of factors does not change the product. All right? They can change back and forth between different cliques, different groups, and it doesn't matter. It's still the same product. So let's look at our example. Our example is 2 times 6 times 3 with the 2 and the 6 grouped together, or 2 times 6 times 3 with the 6 and the 3 grouped together. All right? Here you get 12 times 3, which is, let me pull this up one more, 36. Here you get 2 times 18, and you still get 36. Okay? So we've got, you can change the order of them, right? Commuting means somebody changed position. Associative means nobody changed position. Just the parentheses grouped different factors together. You got the difference between those two? Some of you struggle with the addition, and when you would see numbers changed, you would say it was associative. But if there is numbers that changed position, they commuted, right? So they need to go into the commutative property basket. The next one is the identity property of multiplication, which is similar to the identity property of addition. So what do you think the identity property of multiplication is? Gabby, what do you think?
When a number is multiplied by 1, and it's still the same number.
When a number, she says, multiplied by 1, it keeps its identity, right? That's why we call it the identity property. The product of 1 and a number is the same as that number. Here's some examples. 8 times 1 equals 8. 1 times 8 equals 8. Same. If you multiply a number by 1, it keeps its identity. That's why it's called the identity property. Now, you should really never forget those three, right? Because the answer's in the name. Always think, okay, what does the name mean? Commute, associate, or identity, right? And then look at the problem and see what it is. Now, there was only those three, but we have a couple extras. The zero property of multiplication. Actually, we had a zero property of addition too. What do you think the zero property of multiplication would be? Think about it. Everybody think in your mind, if there's a zero property of multiplication, what do you think it says? What do you think the rule is? Romy, you want to take a stab at it?
There's only 0.
Kind of, sort of, but there isn't always a zero. Zachary?
When something is timed by 0, it's going to be 0?
Yes. How right you are. You have to think, well, it has to do something with 0. So the product of 0 and a number is going to be 0. 12 times 0 is 0. 0 times 12 is 0. Got it? Who thinks those four are pretty easy? You could look at a problem and say, oh, that's the associative property, that's the commutative property, identity property, and the zero property. You think you're good? Good. Why? Because those are the easy ones. And then we're going to talk specifically about a certain new one that I think might be new to you. So I need all eyes, all ears, nobody looking around, nobody daydreaming, no pencils in your hand. I'm going to ask that you close your math book or flip it over just so you're not distracted, okay? Because you're going to need to turn your brains on. That was a little bit of review, and you could probably get that even if I hadn't taught it to you. But now we're going to head into something a little bit different. It is called the distributive property. What base word do you get when you hear distributive property? What's the base word that we can kind of think, this is a clue to what it means. Kayla? Distribute. What does distribute mean? To spread out, right? You distribute something. You kind of spread it out in a different way. And that's exactly what the distributive property does. It distributes a number out. So let's watch this. And we're going to do several examples of this. So let's put this up here. Okay. If we have this right here, I want everybody to kind of focus on this right here. All right? So the distributive property, when the same factor is distributed across two addends, the product does not change. Okay, well, what does that mean? Let's break that down. When the same factors are distributed or separated across two addends. What are addends? These are addends, two things you add together. That makes sense. So when a product is distributed amongst two addends, the product does not change. Here's how you're going to do that. Watch. Actually, I'm going to unbox this because I need this to kind of... If you take 6 times 2 plus 5, it's the same as if you said, watch this, I'm going to distribute this 6. I'm going to distribute it amongst these two addends. 6 times 2 times 5 is the same as saying 6 times 2 plus 6 times 5. I just distributed this 6 to the 2 and to the 5 separately. So 6 times 2 plus 5 in parentheses, you can get these out of the parentheses by saying, it's the same as saying 6 times 2 plus 6 times 5. Do you see what happened right there? Okay? Because look at 6 times 7 is the same as saying 6 times 2 is 12 plus 6 times 5 is 30. Both of them equal 42. So let me do a couple more examples of the distributive property because that's the harder one. If I take, let's see who can get this. I'm going to do one and I'm going to see if you can get it. Do you all have whiteboards?
Yes.
No.
who forgot to get their whiteboard out this morning? Oh my goodness, look at all of you people. I should be getting rich taking dollars from all of you. Remember, first thing in the morning, your materials stack should include a whiteboard.
This is the only thing I always forget.
So if you're getting it right now, you should be doing it quickly and quietly so we can move on really quickly. I won't take $1 from you today because I'm feeling quite gracious. But from now on, I'll be taking $1. You need to be ready in the morning. That's morning ready. Okay, so quickly. Put your expo marker down because I would like to do one more example myself before I give you some, okay? So expo markers down. I'm gonna wait till they're all down, out of your hands. Down means out of your hands. Yep, we'll wait for everybody. Okay, and you can actually put your math book away. We're gonna use whiteboards right now, so just put that away. All right? All right, so let's look at this. If I have 6 times 3 plus 4, and I want to rewrite this using the distributive property. So I've got some eyes that are looking in other directions. I need your eyes to be focused right here. 7 times 3 plus 4. Let's distribute this 7. 7 times 3 plus 7 times 4. Does that make sense? You're adding 2 different things together. You're distributing it so that you're adding 2 different things. Does that make sense? Look at these operations, because sometimes people will get the 7 and the 3 and the 7 and the 4, but you have to know it's multiplying the 7 times the 3 and adding it to 7 times the 4. You can just distribute it amongst those things. 7 times 3, 7 times 4. Got it? You think you got that? I'm going to give you one of those, and then we're going to do some examples together. Let me, not used to using my regular erasers. Okay, so go ahead and try this one. Use the distributive property to write me another math expression that is equal to this one. Flip your boards around when you think you've got it. Write it nice and big. What?
You have to add it.
You do not have to actually do it. I just want you to write the expression. Yes, ma'am. Yes, sir. Yes, I'm sorry, you wrote the problem down too. That was confusing me. Kurt, I want you to actually write it out. I don't want the arrows. I want the actual expression. Yes, Jaden. Yes, Lydia. Zachary, no. You need to distribute it amongst both products. Yes, Eli. Yes, Bria, you're good. Yes, Kayla. Peyton, good job. You got to finish it. This factor is distributed amongst both the add-ins. No, Joey, you only distributed it to the one. You have to also distribute this factor to, nope, Kayla, try again. Romy, I need some parentheses in there to show me what's grouped together, okay? So that's right, Zachary, but what are you going to do with those 2 things? You're going to add them together, you're going to divide them, subtract them, what are you going to do? No arrows. I just want to see an expression without arrows, okay? Yes, that's right, Juliet. That's good, except for there's no 7 up here, Romy. So what number would that be? You just made that up in your brain. No, Kurt, let me show you. Okay, this is what you should have done. All eyes up here. You take the 13. All right, watch up here, especially if you got it wrong. I need your eyes. That means you really need to focus up here right now. 13, and you're going to distribute it to the 1. So watch. 13 times 1. Write that in parentheses. 13 times 1. What are you going to add to that? You're going to distribute the 13 to the 5. 13 times 5 in parentheses. Those of you that got it wrong, do you understand?
Yes.
13 times 1 plus 13 times 5. You're going to separate them. You're going to distribute this 13 to the 1 and then distribute it to the 5. Okay? Zachary, please don't do that, okay? Because people want to focus and that's a little distracting for them. Okay, I think you got it. Let me do one more and then we're going to move on to doing all sorts of the different examples and see if you can tell between them. All right? I would like, how many people are here? 2, 4, 6, 8, 10, 12, 14, 16, 17 people. I would like 17 correct answers so we can move on. Let's try this one. Please rewrite this into an equivalent expression using the distributive property. An equivalent expression. Try to write really big because, you know, my eyes just can't. Okay, yes, that's correct. Yes. I need a long string of things. I need parentheses. Yes, and yes, and yes, and yes, and yes, and yes, and yes. That's right, Kayla, but what are you going to do to those two sets of parentheses? Yes. So here we go. You were right. Here's what, Kayla, can I use yours as an example? So Kayla wrote this, guys. Look up here. This is what Kayla wrote. She's partially right, but would still get it wrong. She wrote 27 times 8 in parentheses, and then she wrote 27 times 9. She distributed the factor between both the addends. But now what do you do with those two things?
Add them.
You add them together. Okay? You were right there, Kayla. All right. Good job. I think you guys have it.
Wait, so that's all you have to do? You don't have to find out the answer?
No, not right now. We're not even finding the answer.
Oh, that makes a lot more sense.
Now, I would like you to tell the property of the problem that I'm going to give you. You can either write C for commutative, A for associative, I for identity, Z for 0, or D for distributive. You know all 5. So which one is number 1? Wait, let me make these a little bit smaller. Okay.
I can't.
Show me number 1. I'm going to put it way up here.
Oh, yeah, I see.
Number 1. Oh, God, sorry. I'm writing the way I tried. Number 1, 5 times 3 times 1 equals 5 times 3 times 1. Okay. Yes, yes. No, no. Yes, 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 yes.
Whoops.
Yes. Yes.
Wait.
Nope. No. Yes. Okay. Some of you, this table right here, I need you to be quiet. Okay, no more talking. All right, if we have to separate, let's just separate because I want you guys both to be able to focus. I don't want one person distracting the other. All right, look at, some of you, as soon as you saw parentheses, you were like, oh, distributive property. But look at, we didn't actually distribute anything. It's, if you just look at the numbers, it's 5 times 3 times 1, 5 times 3 times 1. The only difference is they grouped the 3 and the 1, and they grouped the 5 and the 3. So that means it's different associations. So it's associative. All right, go ahead and do number 2. Everybody better get this right. Do number 2.
Gets wrong. Everybody gets it wrong.
Everybody gets it wrong. Okay, yes, it is the 0 property. Any number times 0 is going to be 0. What about number 3? Number 3, pretty easy this one. Look at number 3.
That might be backwards. Yeah, that's backwards.
Okay. No, Kurt. Everybody else. Yes, Kurt. Look at this one.
What do you put?
Oh, whoops. Oh, yeah.
Zachary got it wrong too.
Yeah, I got it back.
Kurt, the math smarty, had a brain lapse for a moment, didn't you?
What do you mean, math smarty?
He's a smart math student. He just looked at it and was like, oh, I think I'll put identity down there. Okay. All right. Here we go. Number 4. Number 4. Kurt, my math man, don't disappoint me now. You got this one.
Just jinx her.
He is not getting it wrong.
We're just trying to jinx him.
Yes, see, Kurt, I knew you knew what you were doing. All right, yes. Kayla, thank you. Okay, thank you. Okay, we're gonna get a little bit harder because that's way too easy for you guys.
That's
Here we go.
Too easy.
Okay. Complete the number sentence to show the given property. What they're going to do is they're going to leave a blank and they're going to say, what goes in this blank if we are using the identity property? What goes in this blank if we're using the zero property? Probably a zero. Okay, let's look and see number 5. If you are using the identity property, what would this 2 blanks be? This one and this one. You're going to have 2 numbers on your whiteboard. That's it. Don't write the whole thing. Tell me this number and this number. Yes, 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 yes. Yes, good job, guys. Yes. Yes, Romy. Yes, Kayla. Kurt, just give me these 2 spaces. Don't give me the whole expression. I want 2 spaces. Just give me, I'm going to only see 2 things. Jackson, same thing. I only want to see 2 things. Shh, 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 shh. Guys, I should see 2 things, 2 numbers. Yes, Kurt, perfect. All right. Yes, Zachary, remember I said I want to see 2 things on your board. Don't write everything out for me. I should just see a 1 and a 12. This is what I should see on your board. I should see 1, 12, right? 12 times 1 equals 12. That's the identity property. Moving along to number 6, okay? Distributive property. 18 times 15 plus 12 is the same as saying 18 times what plus 18 times what? There should be 2 numbers right here. Let's see if we can get them. Yes, 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 yes. Put yours down when I say yes. Yes, yes, yes. Yes, sir. Yes, sir. Good job, guys. Yes, Joey, no. Joey, look at these 2 numbers. Neither one of them would be 18 because it's 18 times what and 18 times what, okay? You're right there. No, Peyton, check again. Yes, yes. Okay, look, everybody, without talking. Yes, Peyton, that's exactly right. Look at 18 times 15. Look up here, especially if you got it wrong. 18 times 15 goes here, plus 18 times 12 goes there. All right? What about here, number 7? The commutative property. What would go right here? I just want to see 2 numbers. The one that goes here and the one that goes here in the right order. Yes, 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 yes. Still waiting for a few. Yes, 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 yes. Eli, what would go right here? Yes, yes. Put yours down and erase it right away. If you're doing the commutative property. The commutative property. What 2 numbers would go here that would show that you can switch them? Yes, Eli. Okay. All right, I'm going to wait for the talking to be done because I'm losing my voice, so I need all the cross talk to stop in between, okay? Shepherd, shh, in between. 41 times what equals what times 2? In order to make that in a way that you can just switch it around, 41 would be times 2, and 2 would be times 41, right? That would make it commutative. Good job. Next one, associative property. Associative, it means nothing changed. They just are grouped differently. So nothing should change the order. Nothing should change anything. It should stay exactly the same. So what goes here? What goes here? What goes here? In the right order. Yes, 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 yes. Let me see. You missed one. There's 3 blanks. Yes. Yes. There's 3 blanks. What are they? Yes. Yes. Put them in the right order. The associative property means that they did not change their order. Yes, yes. Okay? Peyton, go ahead and put them down, but look at this table right here, next time it's gonna be $1 for both of you, okay? I can't talk to the table behind you when you guys are talking in front. All right? So listen, 4, 5, whatever has to be the exact same order as this one. So this has to be 4, 5, 3. Well, that 3 tells you that that's what's next. 4, 5, 3, 4, 5, 3. Right, Peyton, you see that? 4, 5. How do you know what goes here? Well, look over here. The last number was a 3. And this has to be the same as this one. 4, 5, 3. The only thing that changed was here they grouped the 5 and the 3. Here they grouped the 4 and the 5. All right, so let's go to number next. Number 9.
The new number, I guess.
Number next.
Number next.
What is that called?
So I guess you can vote numbers.
Which number is it?
Number 9. I'm gonna make them a little bit bigger just so people at home can see a little bit
I
easier.
think that's a little bit too small.
Okay, look at what times 18 equals blank times 18 equals blank times 3. If it's commutative, that means everything stayed the same as far as what numbers there are. They just changed position. So it looks like everybody got this one right. Okay, That's in between, guys. Something times 18 equals something times 3. That means these two numbers, these numbers are just switching. 3 times 18 equals the same thing as 18 times 3. Commutative property. How about the zero property? The zero property. What is this and what is this? There's 2 blanks, guys. Yes, this whole, there's 2 blanks, Romy. All of you, that's right. That's right. No, Peyton. Yeah. Yeah. No, Peyton, you're right. Juliet, no, you're not right. Yes, you're right. Any number times 0 equals 0. 0 and 0. Okay, let's move over. Let's do number 10, guys. Distributive property, you don't need to talk to your neighbor to do it. Just quietly look at this. It's the distributive property. So what number is going to go here? You're going to have to look over there and find it. Find what goes here, here, and here. Yes, yes. Peyton, those are not in the right order. Yes, 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 no, yes. Make sure this goes in the right order. This wouldn't be a 4, right? Zachary? That wouldn't be a 4. You have more than 3 spaces in yours, Gabby. No, you have the first one being a 5, right, Peyton? But this wouldn't be a 5 right here. 4 times 5 plus 5 would mean 4 times 5 plus 4 times 5. Yes, Lydia, you're correct. No, Eli, can't change the order. No, Romy. No, Zachary. No, Jackson. Yes, Kayla. Yes, Gabby. If you got it wrong, take a second try at it.
Wait, is this right?
All right, Shepherd's table. Please do not talk in between. There's still people trying to think. Once you get it right, just be quiet and wait. Okay, Jackson, please keep your markers to yourself. All right, because I don't want that middle table. People are still really trying to focus while you guys are drawing on each other. No, Gigi, let's try this again. I'm sorry, Gigi, I think you went on to the next one. Guys, let's look at this one for a second. I want to make sure everybody's on the same page. 4 times 5 plus something. What's this missing number going to be? How are you going to find it? Eli?
We went later into the problem
Yeah, look over here.
and see what is in the problem.
Yeah, you think, okay, if I put this 2 here, and now I distribute it, what would the distributive property say? That would say 4 times 5 plus 4 times 2. Can we fill that in? 4 times 5 plus 4 times 2. Does anybody not see how we got this fill in the blank for the distributive property? That's probably the toughest one to do, is going backwards on the distributive property and filling in the blanks. If you've got this, you'll be fine. That's the hardest. Let's do the associative property. Associate means they are the same numbers in the same order, just fill in the blanks. Same numbers, same order. Yes, 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 yes. Let's get the rest of the people. Yes, no. Yes? There's too many numbers in yours. There should only be 3 spaces. Yes, yes, yes. I'm waiting for Eli, Zachary, Bria. This is the associative property. It means whatever this is going to be the same thing. In the same order, it's just you put parentheses around different things. Yes, Jackson? Okay? So what's going to go in that first blank? No. All right, Eli, walk us through this one.
I don't know.
You don't know it? Okay, that's even better. Walk us through it. If you have 7 times something times 1, and it's going to be the exact same thing over here, what number is missing right here?
1?
The,
Shut up.
Eli, which one? Which one? Here's how you're going to tell. These numbers are going to be the same in the same exact order as right here. Same, same, same. So which one over there is missing that you can find from over here? The 7 is here. Well, that's going to go there. What's going to go here if they're going to be in the same order? Do you understand what I'm doing? So if you have A times B times C is equal to A times B times C. So what they did is they said, oh, let's take this one out of here. Where are you going to find that answer right there? Over here. It's right there. You're going to say, oh, it's B. These are equal to each other. Does that make sense? So Eli, if you have 7 times something times 1, look over here. What is that something going to be? There's only one number it could be. Right here. 7 times something times 1. What would this be? Look up here. What's the only number you can pick out? 5. 7 times 5 times 1 equals, now you have to fill in these blanks, but it has to match. Associative property means it matches. You just grouped them differently. So what would this one be?
7.
Yeah? And what would this one be?
1.
Yes. So these ones exactly have to match. Associative means they match. You just group them differently. All right, let's try and see if we can get any more harder ones because those were pretty easy. Oh, it goes into problem solving. Bummer. Okay.
Kelly.
Let's do one more of those kind that were a little bit hard, and then we're going to switch over to some science. All right? One more. Let me put one over here. Let me get some white space on here. All right. Here we go. I want you to do this associative property one and distributive property one, just to make sure we've got it.
Okay.
Okay, look at this is the associative property. So that is going to equal the same thing over here, but grouped differently. Okay, fill in those blanks. They have to match on both sides. So what is that going to be? Yes, 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 yes. No, yes, yes, yes. No. Put them in order. This would not be a 4 right here. Zachary, think about that one. What would that number be? That would be, you know, I couldn't quite tell you because I was just looking for 3 numbers. Yes, yes, you got it, Gigi. Yes, Zachary, good fix. Nope, it wouldn't be a 6 right here, Peyton, because then the order would be switched. So keep the order the same. Yes, yes. Okay, good job. Guys, you've got it. You've got it. So your homework for tonight is 3-1, the homework part, okay? So I'm gonna put it up here on the board so that you know which page it is. We are looking at page 32. Page 32. I gotta cross all that stuff off. Page 32 is your homework for tomorrow. All right, yes, you can erase that.